Hello everyone. In this video we're going to look at Pythagoras' theorem. We're going to look at what it is and how to use it. Pythagoras' theorem is used in right angled triangles. So first thing you need to make sure of is that you've got a right angled triangle. It doesn't work in non-right angled triangles, so you need to make sure you have right angled triangles for this. Next, you need to identify the side. So you need to know what the longest side is, and that's called the hypotenuse. The hypotenuse is the longest side, it's always opposite the right angle, so it's quite straightforward to find. We label this side C, so we call this length C, and we call the shorter lengths A and B. It doesn't matter which one is A and doesn't matter which one is B, so we'll call one of those A and the other one B. If you've watched the previous videos, you'll know that Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. So the square of the hypotenuse, so that is c squared, is equal to the sum of the squares of the other two sides. So that is a squared plus b squared. And that is Pythagoras' theorem. Okay, let's have a look at this example here. The question says find the length, of the missing side. Well, this is the missing side. So first of all, we need to make sure that the triangle is right angle. Well, it is. It shows it there. Next, we need to identify the hypotenuse. Well, the hypotenuse is opposite the right angle. It's this one here, and the hypotenuse is known as side C. So now we can label these two sides. The hypotenuse is the longest side, known as C, and the other sides are just A and B. So it doesn't matter which order. I'm going to put A as the smaller one, and I'm going to put B here as 6. Pythagoras said that c squared is equal to a squared plus b squared. So all we need to do in order to find side C is to substitute these values in here and here, and then rearrange to find the value of C. So let's look at this. C squared is equal to, well, A is 5, that's 5 squared. B is 6, so that's 6 squared. So we know that C squared is equal to 25 plus 36. So we know that C squared is equal to 61. Now, we need to get rid of this squared. Well, the inverse of squared is square root. So C is equal to the square root of 61. All we do now is put this in our calculator. C is equal to 7.8 centimeters, and that is to 1 dp. So let's look at this question again and establish some steps. So step 1 was identify that you have a right angled triangle. That's the first thing we did. We identify it by the square in the corner here. Step 2 was label the sides A, B and C. Start with C. That was the hypotenuse, the longest side, and that's always opposite the right angle. Once you've written C in, you can label the other two A and B. Step 3 was to write out the formula. C squared is equal to A squared plus B squared. Make sure that you've got C on the longest side. That is the key to all of this. Then what you do is you substitute the values into the formula and solve it. That's what we did last time. We replaced A with 5, so 5 squared is 25. We replaced B with 6. 6 squared was 36. We add those two together and got 61. Therefore, the square root of C is equal to the square root of 61. So C is now equal to 7.8. Okay, on the left-hand side of the screen, you've got two visuals to assist you. You've got at the very top left the straightforward ABC triangle showing the right angle, and the theorem c squared is equal to a squared plus b squared. Below that, this one here, you can see that actually we've got squares on the triangle. That's to help you remember that the square of the two smaller sides added together is equal to the square of the hypotenuse. So the squares of the two smaller sides added together is equal to the square of the hypotenuse. Okay, so it's your turn to have a go. Here's your triangle on the right hand side. What I'd like to do is press pause, have a go, and when you're ready for the answers, press play. Okay, so let's go through this. First of all, we label the diagram. Well, there is the right angle. Opposite the right angle is C. So we label that C. The other two are A and B. Doesn't matter what order. Then we write out the formula. C squared is equal to A squared plus B squared. Once we've done that, we substitute the values. So C squared is equal to 4.2 squared plus 5.6 squared. So C squared is equal to, we put those in our calculator and get the answer. So C squared is equal to 49, and the square root of 49 is 7, so C is equal to 7. Don't forget the units, this is in centimetres, so we have got 7 centimetres. Okay, your turn to have a go. Press pause, try these three, and when you're ready for the answers, just press play. Okay, so for A, we label the side C, A, and B. So we've got the formula C squared is equal to A squared plus B squared. So we know that C squared is equal to 6 squared plus 7 squared. Now we can simplify this. We could just write C is equal to the square root of 6 squared plus 7 squared. Just need to put that in your calculator and find the answer of the hypotenuse. Therefore, C is equal to 9.2 centimetres to 2 significant figures. Remember, this is actually asking for 2 SF, so be careful on that one. Okay, question B, very much the same. Label the diagram. There's the right angle. Opposite the right angle is C, A and B. There's A, there's B. I tend to choose the smallest side for A, but you don't have to do that. So C squared is equal to A squared plus B squared. C squared is equal to 4 squared plus 9 squared. C is equal to the square root of 4 squared plus 9 squared. Therefore, C is equal to 9.8 again centimetres, and that is also to 2 significant figures. Okay, so for question C, notice it's not necessarily flat at the bottom. All you need to do is identify where the right angle is and the opposite side is C. That's all we need to do. Now we've got A and B. I want to choose that as A and that as B. Same thing again. C squared is equal to A squared plus B squared. C is equal to 5.1 squared plus 6.2 squared. Notice the shortcut, I put it straight in there. So therefore C is equal to 8.0. This time you're not in centimetres, you're in metres. So that is M, and again that is to 2SF. So far we've been looking to find the longer side using Pythagoras, but what happens if we want to find a short side? So in this example here, if we look at, say, finding side A, for example. If I want to find side A, all I need to do is rearrange the formula. So we have the formula as it is. I want to find this, therefore I need to get rid of this section here. So to get rid of this section here, I just do the inverse. I take B squared from both sides of the equation. So now I have C squared minus B squared is equal to A squared. Let's rewrite that. Therefore, A squared is equal to C squared minus B squared. We can use this formula to find a short side. Okay, let's do this question. So, first thing we do is label the sides again. There is the right angle, so this side is C. So straight away I've got the hypotenuse, therefore I know I'm finding a shorter side. I'm going to label this one A and this one B. It says calculate the length AB. Well, that's the length AB, so it's our lowercase b. Pythagoras said c squared is equal to a squared plus b squared. Now we want to rearrange this so we have b squared equals. So in this case, if I take a squared off both sides, I end up with b squared is equal to c squared minus a squared. All I do now is substitute and solve. So b squared is equal to 17.55 squared minus 6.75 squared. As before, I can simplify this in my calculator just by putting the whole lot of that under the square root. Pop this in your calculator and you'll get a value for b. Therefore, side b is equal to 16.2 centimetres. Okay, your turn to have a go. Notice on each of these you've been given the hypotenuse, so you are finding the shorter side. Okay. Finally, it says give your answer in surd form. So that means giving it with the square root left in. Press pause, have a go. When you're ready for the answers, press play. Okay, so question A, label the diagram. That's still C. Let's call that one A. Let's call that one B. So I'm looking for the short side B. So I know that b squared is equal to c squared minus a squared. So I substitute for the values in. B is equal to, I can put that under the square root straight away, doing the inverse of that. 4 squared minus 2 squared. Okay, so b is equal to the square root of 16 take away 4. B is equal to the square root of 12. The square root of 12 can be simplified to 2 root 3. So b is equal to 2 root 3. The units are in centimetres, so we need to make sure we finish that off as centimetres. For question B, it's exactly the same, so label the diagram. There's C. I'm going to call this one A, and there's B. This time I'm looking for A, so a squared is equal to c squared minus b squared. A is equal to the square root of c squared. Well, c is 6, so that's c squared minus 3 squared. A is equal to the square root of 36 take away 9. A is equal to the square root of 27. 3 root 3. Again, those units are centimetres. And finally, question C. Again, find the right angle. Opposite the right angle is the hypotenuse, so that's C. Let's go for A and B. We are looking for A. So like before, a squared is equal to c squared minus b squared. A is equal to the square root of 15 squared minus 10 squared. A is equal to the square root of 125, which in surd form comes out as 5 root 5. Again, that is in centimetres. Okay, so what about more complex questions like this one? Calculate the length of AD. Well, that's that side there. Okay, so there's AD. Now, in order to find AD, we need to find AC first. So this is the missing side we need to find first. We can find this side because we've got two sides of the right angle triangle already. We only need to use those two sides to find the third one. So our first triangle to look at is ABC. So we're looking at triangle ABC. So let's label these sides. Well, that's opposite, so that is C. Let's call this one A, and the one that's missing, let's call that B. At the moment, I'm actually ignoring this triangle here completely. So I'm just looking at the highlighted one. So we want B. So in that case, we have got B squared is equal to c squared minus a squared. Again, substitute and rearrange. So b is equal to square root in b, so we're square rooting this side. The square root of c squared, or c is 19, so 19 squared minus a squared, which is 14 squared. So therefore, b is equal to the square root of 165. Let's leave it in that format for the moment, okay? So now we've got a value for b, and b is equal to the square root of 165. Now here we've got another right angle triangle, so we can use side AC and side CD in order to find the length we're looking for, this one here. So let's label those three sides again. We're looking at the right angle for this triangle. That's the hypotenuse, C. The other two are just A and B, so let's call that one A and let's call that one B. Okay, so in this case we know that C squared is equal to A squared plus B squared. Let's substitute and rearrange. So C is equal to the square root of A squared. B is the square root of 165 squared. Now the squared and the square root cancel. So now what we've got is C is equal to the square root of 100, that's 10 squared, plus 165. So the square and the square root just cancelled. So therefore, pop that in your calculator and you'll get the length of side AD. And that is 16.3 meters, and that is to 3 significant figures as it asked for in the question. Okay, it's your turn. So press pause and have a go at this question. So you're going to calculate the length of AB. Off you go. Right, so here are the answers to this question. So first of all, we're looking for AB. So side AB is this one here. All right, so that's the side we're looking for. But to find AB, I need 2 lengths. If I'm going to use Pythagoras, I need 2 of the 3 lengths. So I haven't got this length here. So I need to look at this other triangle, ACD, and I need to find this length first, AC. Now if I ignore the top triangle, if I look at this, I've got a right angle triangle. Opposite the right angle triangle, I have got the hypotenuse. I'm going to label that one C. I'm going to label that one A and that one B. So now I can see I've got 2 lengths of a right angle triangle. I can use those 2 lengths to find the third length. So here goes. So C squared is equal to A squared plus B squared. So C is equal to the square root of 4 squared plus 7 squared. Therefore, C is equal to the square root of 65. Now leave it in this format at the moment. So we know that C is equal to the square root of 65. Okay, let's cross those labels out because we've used those and we don't want to confuse them with the next part. We have now got another right angle triangle and we have got 2 known sides. We can use those 2 known sides to find the unknown, AB. Now label side C first, label the hypotenuse opposite the right angle, so that's C. Let's call this one A and let's call this one B. So in this case we are looking for side A, we're looking for a short side, so that becomes A squared is equal to C squared minus B squared. So A is equal to the square root of 9.5 squared minus the square root of 65 squared. Now, like last time, the squared and the square root cancel. A is equal to the square root of 9.5 squared minus 65. Pop that in your calculator and you get 5.02. That one is in centimetres, and again to 3 significant figures. The last 2 questions for you to have a go at, you can see that that is not a right angle triangle, and nor is that. So you have to try and establish a right angle triangle in there somewhere. first in order to find length BC. Likewise with this question here. So press pause, and when you're ready for the answers, press play. Okay, for this one here, you're looking for this length. Now you can see there isn't a right angle triangle here, so you have to create one. So we'll just take this across here, make those two parallel, make it a rectangle, so that becomes a right angle triangle. You have now got this side here, which is 15. That's the key bit. So if you look at this, labeling this, that is C. Let's call this length here A, and let's call that side B. So we are looking for side A, so A squared is equal to C squared minus B squared. A is equal to the square root of 17 squared minus 15 squared. A is equal to 8 centimeters. So now I've found A, I can answer the question, calculate length AB. My apologies, calculate length BC, that's BC, so I want that length there. So that length is, so BC is equal to the height of AD minus A. So it is 12 minus 8, which equals 4 centimeters. Okay, looking at this question here. With an isosceles triangle, we can actually drop a vertical here and split this into two right angle triangles. So we can literally put a right angle there. We then know that distance is actually 4 centimeters. It says calculate the perpendicular height. That means it wants the height from A to the base at the right angle. So we are wanting that height there. Well, that's easy enough. We've now got this right angle triangle. There's the right angle. Opposite the right angle is the hypotenuse. We are looking for, let's call that side A, and we have got side B. So A squared is equal to C squared minus B squared. A is equal to the square root of 10 squared minus 4 squared. So therefore, A, which is the perpendicular height of ABC, is equal to 9.17 centimeters to 3 significant figures.